Okay, a particle is projected from a point on a level horizontal ground at angle alpha to the horizontal ground. Find alpha, the horizontal range, and it's 7 times the maximum height reached by the particle. Now, it's going to be quite the shallow angle, because if you throw it really high, the height is going to be much better than the distance. It's like playing Angry Birds back in the day. It's going to be something like that. Okay, where the greatest height is better than that. Right. Now we're going to create a triangle here. We're going to call this speed u because we don't know anything about it. We know that it's part of angle alpha, so that's u cos alpha, u sine alpha. We're then going to use phi equals u plus at, and s equals ut plus a half at squared. Okay, and then we're going to get phi x equals u cos alpha. Gravity acts straight down, so there's nothing in the way there, is there? There's nothing opposing its motion. Phi y is u sine alpha, which is acting directly up. It's opposed by gravity on the way down. Is that okay? Now, Sx is speed multiplied by time for ut. So it's ut cos alpha. Sy is ut sine alpha minus a half gt squared. What's the deal? What's the relationship, lads? What's the relationship between the time for highest point and the range when it comes to flat throws? One of them is half the other one. Does everybody get that? It's symmetrical when it's on flat ground, and when you're starting and finishing at the same level. The time taken to go up is equal to the time taken to go down, which means the time of flight is twice the time for the highest point, alright? Now let's go for this way. At the highest point, what are we guaranteed? Phi y equals 0. So what we can then say is that gt equals u sine alpha, and your time for highest flight is u sine alpha over g. What's the time of flight there for? Anybody? Time of flight? We know the time for the highest.
Twice that.
What? Twice it. Is that right, Phelan? Twice it? Okay. Now, we're going to find the greatest height. Height is an SY equation. So height is u times 2u sine alpha over g, and a half g. Now t squared is u squared sine squared alpha over 2g, like so. Oh wait, not 2g. Square that. Sorry. Square this one, and g squared on the bottom. Sorry, I was just skipping the next step. I was. Alright. You're going to get 2u squared sine alpha over g, and then we're going to get, what's that? The g's cancel. So sorry, look at that. I used the time of flight, not the time for highest approach. So there is no 2 there. It's just u squared sine alpha over g. Make sure you use the correct time when they're both looking at you in the face, okay? And then what we should get is u squared sine squared alpha over 2g. 1 take away a half is a half. Give them a common denominator, and you end up with u squared sine squared alpha over 2g. that right for the greatest height? Now go back up, and this time you're going to do the range. Now you're going to do the range, okay? And for the range is an SX formula. So range is this one here, and it's going to equal U times T, the time of flight that is, and that's times cos alpha, and then you're told it's 2U squared sine alpha cos alpha over G. Alright guys, what you're told is 7 times the height equals how much of the range? 7h equals R is essentially what you're told. So multiply your H equation by 7. Leave your R equation alone and isolate an angle because you want the angle at the end of the day. So sine alpha cancels with one of the sine alphas over the other sides. The U squareds cancel, the G's cancel, and what you'll be left with is 7 sine alpha over 2 equals 2 cos alpha. And anybody who's doing maths a long time is, you know, to throw the cos alpha underneath the sine alpha to make tan alpha. So the cos alpha goes to the bottom left, then we have 4 over 7, and then we have tan alpha equals 4 over 7, which is 29.7 degrees. Okay. Alright, let's move on. Okay. A paragon is projected down a slope. Now, lads, unfortunately, most of you saw up a slope. A lot of you saw up a slope when it's clearly down a slope. So that means your equations were slightly off at the very beginning. Okay. So you're not starting down here. You're actually starting up here, and you're firing it downwards. Okay. And what we're told about this is that's 45 degrees. That's angle alpha. Okay. Now, what we're going to do is the usual. We're going to call that U. You're going to be U sine alpha, and you're going to be U cos alpha. We're then going to work our way to using a gravity triangle, like so. What's it? Straight across, perpendicular, and parallel. That's our gravity triangle there, which is 45. And in our gravity triangle, that's going to be G cos 45 and G sine 45. I'm inclined to put them as square root of 2 straight away, so it's going to, for me it's G over root 2 and G over root 2 there. Now we're going to make our 4 equations. Yes? Yeah, of course. Now, U cos alpha, going directly down, it's being accelerated. So U cos alpha is being accelerated by this G over root 2 going downwards. Okay? So it's addition, not subtraction. So it's going to be G over root 2 T. Py is U sine alpha. It's going to be, it's in the opposite direction. So it's take away GT over root 2. Now you go for Sx and Sy. Sx is add on a t, ut cos alpha, half the second one, plus g over 2 root 2 t squared. Sy is ut sine alpha minus g over... Oh, made a mistake. Anybody care to elaborate my mistake? It's very obvious. Happens a lot after you do a part A. What do you forget to do? Actually, you haven't made a mistake, never mind. I was thinking I forgot to break up gravity and put it in, but as it turns out I did. Just never mind. Yeah, the common mistake is with the gravity. Some people just leave it as G and forget to break it up into its components. But anyways, I actually did take care of that, never mind. It's good to always assume you're wrong and double check. Okay? Alright, we're all good. Now, what on God's green earth does it want from me? Particle hits the slope after 3 seconds. What does that mean? Time of flight is 3 seconds. How do you find the time of flight? Sy equals 0. So we're going to get ut sine alpha equals gt squared over 2 root 2. The t's will cancel. And we get t equals 2 root 2 u sine alpha we don't need to do that, do we? What does it want from us again? It wants us to find the angle. So I actually don't have to isolate t at all. What's the only thing I have to do here? Just sub in 3 now, don't I? So just sub in 3. So anywhere you see a t, put in 3, you're going to get u now the only problem is the so you just have to give me a sec here. We actually have a u value, don't we? Sorry lads, the u value is, everybody see the u value is 9 root 2? So technically speaking, all these equations should have a 9 root 2 in it. So we knew that u was 9 root 2, so this should all be 9 root 2 right here. So yeah, so we just go back a step here actually, and we can say that this is once again sy equals 0, and we can say that that's 9 root 2 t sine alpha. Just sub in all the 3's, and here's what you get. You should get 27 root 2 sine alpha equals 9g over 2 root 2 sine alpha equals 9 times 9.8 for gravity. 27 times 2 is 54. Root 2 by root 2 is 2, so it's going to be 54 times 2. Sine alpha equals, where did I put this? I think I left it as g, but look, we'll do it here. 9 times 9.8 divided by 108. 49 over 60, I believe. And sine inverse 49 over 60. You get alpha equals 54.75. I think most of you got that alright, yes? Yeah. Did most of you get that okay? Wasn't too bad. Alrighty. Next thing we have to get is the landing angle. What is the landing angle again, lads? If we call this L, what does that mean? What do you need to know for L? Yeah. Tan L equals minus Vy over Vx at time of flight. Now, what do we know about the time of flight? Time of flight's 3 seconds, lads. So that's handy to know. So we'll just go back up to the top and we sub in 3 seconds for the time of flight. I think I actually made a meal out doing this question compared to other people. Now, planet angle. Oh, sorry lads. Read the question really closely. It's not 3 seconds anymore. Why? It's a separate question. You need a new value of A, which means the time of flight is no longer 3 seconds, okay? So I didn't make a meal out of it, I actually did it right. Okay, so if I go back a couple of steps back here, and what we're going to do is going to find out the time of flight the way we normally do. Cancel off the t's. 9 root 2 by 2 root 2 is actually 36. 36 sine alpha over g equals time of flight. There's your time of flight right there. Okay? What do we know about phi y when we do all this? What do we have to know about phi y when you do all this? Phi y has to be negative. Okay? So when we insert the time of flight, phi y must be negative. Okay? So let's do this now. Alright. Hey Ali. 9 root 2 cos alpha plus gt. So g over root 2 times 36 sine alpha all over g. Phi x is 9 root 2 cos alpha. What's that? 18 root 2, isn't it? Okay, do the same thing for Vy underneath. And as I said earlier, Vy has to be negative because it's landing. Okay? If it's not negative, something's wrong. Now, this is basically going to turn into 9 root 2 take away 18 root 2, which is minus 9 root 2 sine alpha. And now it brings us to this part here. Yellow part. Blue part. Okay. Now, tan L is what, lads? Tan L is a quarter. A quarter has to equal 9 root 2 sine alpha over 9 root 2 cos alpha plus 18 root 2 sine alpha. Cross multiply and you should get 9 root 2 cos alpha plus 18 root 2 18 root 2 sine alpha and then that equals 9 root 2 sine alpha. Oh god, what did I do wrong? I forgot to multiply by 4, didn't I? So that's 36. Thanks for that, Mick. So that's 18. Can I just get rid of all the root 2's? They're really annoying me. So 18 sine alpha equals 9 cos alpha, and thank God we're going to get a sine alpha over cos alpha, which is tan alpha, and that's going to equal 9 over 18, which is a half. Tan alpha equals a half, otherwise known as 26.56 degrees, and we're good.